Hello, so we're just doing AC4 January 2012 Edexcel question on vectors, which was done in Havant South Downs College, Havant campus as their test, question 2. Wasn't too bad. Question part A, just a normal kind of intersection of two lines. Only 3 marks because the working was much easier than some of these questions, and they've also told us that they already meet, which just makes things a lot simpler because we know they meet. Just makes it a bit quicker. So 2 plus lambda. That's well, I'm just writing it in column form and bringing the columns together. Then 3 plus 2 lambda. This is line L1, and minus 4 plus lambda. That's line L1. Line L2 will be 0 plus 5 mu, 9 plus 0 mu, so that's just 9. That's one of the things that makes it much quicker actually. So it's minus 3 plus 2 mu. Now normally we equate these and we equate everything and just check 2 of them and check with the other, but we can get only one value of lambda could possibly work here, because if we look at just the j bit, we have 3 plus 2 lambda equals 9. Now you might have equated the I first and then come to the j, it doesn't matter, but what I'm saying is this makes it very quick because we don't have a simultaneous equation. Only one value of lambda will work. That gives me lambda, 2 lambda equals to 6, so lambda equals to 3. And if lambda equals to 3, because I now look at the I bit, I get 2 plus 3 equals 5 mu. So mu must be equal to 1. So now what we can do is put 3 and 1 into these, or these. Let's put lambda as mu into 1 here. So that gives us and it wants a coordinate here, so we want to write in coordinate form. The I bit, so the x coordinate is 5 times 1, which is 5. This is 9, obviously, because it has to stay at 9, and minus 3 plus 2 times 1, so that's minus 1. Okay, I might check that lambda equals 3 and works here as well, so lambda equals 3, 2 plus 3 is 5, 3 plus 2 times 3 is 3 plus 6, which is 9, and minus 4 plus 3 is minus 1, so it's definitely correct. It's nice to know. Okay, let's have a look at the next question. Typical, kind of slightly different, but basically find the angle between two lines. So let's just do a little diagram to help us here. So let's draw line L1, line L2. We've got the point of intersection which we've just found, which is C, which has, let's write it as a position vector, 5, 9, minus 1. 5, 9, minus 1. And then point A lies on line L1. Let's call this line L1. Point A. Now if I put lambda equals 0 in here, I get A. OA is 2, 3, minus 4. That's OA. And that corresponds to a value of lambda which is 0. Remember the value of lambda here was 3. Okay, and then the coordinate B, let's say here, that's OB, that's putting mu is equal to minus 1 in here, so that gives me minus 5. 9, because obviously that stays at 9, minus 5. And that corresponds to a value of lambda equal to minus 1. Not about lambda, mu is equal to minus 1. And what we're being asked for is the angle between them, let's call it theta say. Now we know easily to find the angle between two lines. It hasn't asked for the acute angle here, so it is we have to allow for the fact that it could be obtuse, and we need to be careful. Now, what most students did, that is marked on this, is they found the difference between this vector and this vector, and then this vector and this vector, and worked with that, which of course is going to give you the correct answer. I'm going to try and cut a bit of time, because of course we know the direction vectors of these. So long as we make sure the direction vectors are going the right way, this vector here, because it's going 0 to 3, that vector there is 1, 2, 1. And similarly, as mu increases, that vector there is 5, 0, 2. And so I know that because these are going in both into each other, that the angle that when I find the dot product, I won't need to modulate it. If it comes out negative, it's because the angle's obtuse, basically. It doesn't actually, it becomes acute anyway. So I'm going to use these vectors basically rather than work out these. You might say, well, you've talked about this long enough and I could have done it by now, which you could have done, but when I actually did it, obviously it just occurred to me that this would be quicker. Right, now, so I'm just going to work out cos theta, the dot product, that's 1 times 5 on top, 1 times 5, plus 2 times 0, it turns out, plus 1 times 2, all over the moduluses of these, so that's 1 squared plus 2 squared plus 1 squared, and 5 squared plus 0 squared plus 2 squared. Which comes to, I think, 7 over square root of 6 is square root of 29. That gives me, when I find the inverse cos of that to 3 significant figures, 57.9 degrees. Okay, so now to the next part. We now know the angle between them. The next part is to find the area of triangle ABC. Now, I should be able to work out the lengths AC and BC reasonably easily, and I know the angle in between. So the formula I'm going to use is half AB sin C, or that formula where basically if you know the lengths of the two sides and the angle in between, we can work out the area. So we just need to work out the lengths of these. Now I'm not bothering to worry about working out the vectors and then the moduluses. I'm just going to find the differences of the components and square them, and then add them and square root it. So the length, let's write it out separately, let's not rush it too much. AC is equal to the square root of the difference between the x coordinates, so that's 3 squared, plus the difference in the y coordinates, 3 and 9, that's 6 squared, and the difference in the z coordinates, minus 4 to minus 1, that's also 3 squared. So that comes to the square root of 54. And BC equals to the square root of the difference in the x coordinates is 5 and minus 5, so that's 10 squared. The difference in the y coordinates is obviously 0 squared, and the difference in the z squared is 4 squared. So that's the square root of 116. So I'm going to use that. So let's put them in there. So we've got the length of AC is the square root of 54. The length of BC is the square root of 116. And then it's sine the angle in between, which is 57.9. I've got the number stored on my calculator slightly more accurately than that, to avoid rounding errors. And that comes to 3 significant figures, 33.5 degrees. To 2 significant figures, it's 34 degrees, but 33.5 is to 2 significant figures, or 33.54 indeed was also accepted to 4. Okay, so that's that question done. January 2012 done, and hopefully that was useful. Thank you. Bye.